First of all, thank you so much for the entire React Rally team for inviting me over here. We know how conferences have been for the past 2 years, how difficult it has been economically. So I would just want everyone to give a huge round of applause for the React Rally team, just for organizing this event and seeing so many amazing speakers from around the world coming over here. So if we can just have a quick round of applause. Now, the way that I got to know about React Rally was in 2019. One of my friends, I was still in college of my final year, and one of my friends got a scholarship to actually attend a React Rally, and that was the first time I got to know what a conference is, and there are scholarships. That year, I was able to attend my first ever conference on a scholarship as a student, and here I am presenting at React Rally, so dreams do materialize. And with that, I'll be presenting today on server-side rendering with the help of WebAssembly. A quick introduction about myself. I'm Shivay. I'm a developer relations engineer at Millisearch. It's an open source Rust-based search engine. And I'm also an ambassador for Wasm-based, which I'll be, of course, speaking a lot more today. It's an open source WebAssembly runtime. And I'm also TensorFlow.js SIG and working group lead from India. Now, of course, let's kind of take a look at a basic primer on server-side rendering. For those folks who might be still new to this particular concept, it essentially means that you're able to take your code, whether it's your components, your React components, and just preload them when your app launches for the first time, without having to actually load the JavaScript. So your page will render that HTML beforehand so that it helps with SEO and also does help with being able to load your components faster. Of course, there are some downsides to server-side rendering as well, but we'll not touch upon those. Now, if we kind of look at what are some of the traditional ways in which people might actually implement SSR. So, of course, you have a lot of very famous, particular frameworks that have been written in React, for example, Next.js, that do support server-side rendering out of the box. Now, of course, if you wanted to implement server-side rendering in your own application and you're not using any framework, you could do that by essentially creating, let's say, an Express server and taking that HTML code and serving that to your React app with the help of this Express server. And of course, we have seen a lot of improvements of SSR support with React 18 with the help of the suspense library, and of course, with the lazy loading that comes with this suspense SSR. So with React 18, you're able to support it out of the box. And you have support for both, whether you want like static or even streaming SSR. Of course, and if you are well aware of this particular, this React 18 and how SSR has kind of been so well accomplished in SSR, you might also be aware of this particular meme about the improvements that we have actually made to SSR in React 18. But of course, the topic that I'm going to be covering today is how can you achieve server-side rendering with the help of WebAssembly. Now, this might raise a lot of questions. A lot of you might not be aware of what WebAssembly is, or might be wondering why another approach to a problem that has already been accomplished so well, right? We have Next.js, we have suspense in React 18, so why just introduce another method? So I'm here to answer all those questions for you. So first of all, of course, what exactly is WebAssembly, right? We are at a React conference and we are all JavaScript developers, so we should know about WebAssembly because it has been and it will be an integral part of, you might not use it in a day-to-day manner, but you will definitely come across it from time to time. So let's first take a brief look into what exactly is WebAssembly. Now, at its core, WebAssembly is not a programming language. It's not related to assembly or not just related to web. But think of it as this efficient, low-level bytecode that is typically a compilation target for more performant programming languages like Rust, C++, or even today it has support for more of your, the common languages like Python, the scripting languages like JavaScript, Python that can actually be compiled into this WebAssembly binary. And the way that this works out is that this is a compilation target that you can actually use within the browser or even, in fact, outside the browser. And it's meant to be able to actually reduce some of the performance issues that you typically find with JavaScript. So you'll actually use, you'll see WebAssembly being used to take, let's say, something like FFmpeg, which is a very popular C++ library that allows you to work with video codecs. So you'll see that being used for being able to do in-browser video editing, or even Figma uses it for being able to handle large type of file manipulations, or even Photoshop for that matter. And these traditionally could not have been performant with JavaScript. And essentially, you will inject your WebAssembly binary as this compilation target. You will inject it inside of your web application with the help of JavaScript and load it and run all those performant tasks with the help of WebAssembly. But of course, why should one care about WebAssembly in the first place? So first, it's very quick. Now, it's not going to be as quick as, let's say, a native binary that you might want to run. But of course, it still runs at near native speeds in comparison to most of the binaries that you might run. Now, it is also extremely secure. So by default, the WebAssembly binary itself cannot do anything, right? It cannot interact with the file resources. It cannot interact with the network resources. So you need the actual browser VM to be able to actually run these WebAssembly binaries. But what that means in retrospect is that it is highly secure, and you can run applications very securely with WebAssembly. And of course, the third one is it is also highly portable. So as this binary target, it's not just meant to be run on the web. In fact, today you see a lot of use cases for WebAssembly and JavaScript on serverless, on being able to run JavaScript on edge applications, because we're seeing so many edge devices being there. So this WebAssembly target can support multiple different type of device architectures, whether it's x86 or x64 or different type of edge devices as well. So that's what makes WebAssembly so desirable as this compilation target that you can target across multiple platforms. It's also performant, right? So of course, the biggest question then would be that how are people actually using it right now, let's say with the help of React. So there is one case study that I would like to highlight is by Fiberplane. They are building some really cool stuff. So you can check out this blog that they have written on how they are actually implementing custom reducers. Instead of writing it directly with, let's say, a standard Redux library, they are actually implementing it in Rust and using Wasm to be able to actually render these reducers. And that actually works out well for them because the Rust implementation is a lot more performant. But I'll definitely recommend you to check out this blog post to learn more about some of the performance improvements that they get by actually implementing these reducers in Rust. Some of the other ways that you can actually use Wasm is with the help of, let's say, machine learning libraries like TensorFlow.js, which have a WebAssembly backend. And what I mean by backend is that you essentially run the WebAssembly module on the browser itself, but because it is more performant in comparison to standard JavaScript, you get much more faster machine learning inference with the help of these libraries like TensorFlow.js. So you could use these with your React applications to make performant machine learning capable or AI driven applications as well. Of course, my talk is not going to be about these, but there is going to be one talk, I think, about LLMs and OpenAI that I'm also looking forward to in this React rally. And of course, that kind of brings us now to the concept of how are we planning to achieve WebAssembly-based server-side rendering. Now, there are some prerequisites that I like to kind of point upon. The first one is introducing two main terminologies that you'll kind of go through, which will kind of cover a lot in today's topic. And the first one is Wasm-based. So what exactly is Wasm-based? Wasm-based is a WebAssembly-based runtime. It's an open source project that is currently incubated under the CNCF, which is the Cloud Native Computing Foundation. And we are going to be also using Quick.js, which is an alternative JavaScript-based engine. It's primarily used for a lot of like small applications, and it works pretty well out of the box with supporting WebAssembly. So of course we know that V8 itself also does support WebAssembly, but V8 is a lot larger in size. So since we are talking about building performant applications and applications that can potentially run on edge devices, we are looking at an approach that is optimized. So we are going to be using Quick.js as our alternative engine for JavaScript. So of course, the biggest point is that how does one actually achieve server-side rendering with the help of WebAssembly? So the Wasm-based runtime, right, is what is capable of being able to actually delegate and execute these WebAssembly binaries, right? So as I mentioned, that the WebAssembly module itself, the binary that you get as this compilation target, cannot do anything on its own. So this Wasm-based runtime is what will be capable of running that sandbox environment for running that WebAssembly modules. And the combination of the WebAssembly and QuickJS project, this is a separate open source project where you're able to actually have a custom QuickJS runtime and you're able to actually execute JavaScript applications with the help of Wasm-based, is what will be responsible for actually taking your JavaScript, your React application, and running that React application inside of this entire Wasm-based QuickJS runtime. So just think of this as the sandbox environment in which you're going to be essentially running your React application. And of course, one might question why to choose this particular approach. So there are two primary reasons that I would like to give, and just a disclaimer, right, that the approaches that I'm going to be talking about in this particular talk is by no means meant to replace the existing server-side rendering that you can achieve with Next.js or even with React 18. This kind of tells an alternative approach to being able to achieve server-side rendering, especially if you're dealing with JavaScript on the edge. Because trust me that today JavaScript is not just limited on the browser itself. You'll find a lot of use cases on server-side, serverless, and even edge applications. So the approach that we are kind of trying to portray is more to do with that how you're able to actually achieve this on, let's say, edge applications. So compared to the normal V8 that, of course, I kind of covered, right, the implementation which Wasm-based and QuickJS provides is a lot smaller in size. So if you are constrained by, a particularly, let's say, an environment, we are trying to run an application, a React application, and of course you want server-side rendering. So if you're kind of hindered by the time and the constraints by the amount of space that you have and the compute, then of course this approach will be a lot more smaller in size and will be also faster in being able to still get those SEO gains that you'll get with server-side rendering. And of course, as I mentioned, that Wasm provides a lot more secure environment. So let's say if you have a particular use case where you want your server-side rendering applications to be more secure, then this particular approach will provide a lot more security in terms of just the Wasm not being able to be executed by anything outside of it, or the Wasm sandbox itself being highly secure. So those are some of the biggest benefits that you will get when dealing with being able to use WebAssembly for being able to do server-side rendering. So let's take a look at how would you actually implement this with the help of a simple create a React app. Now, of course, this approach can work pretty well outside of the box with whether you're wanting to, let's say, you want to create a streaming application. So whether you want like static-based or streaming-based server-side rendering, both these approaches will be possible with the help of this example that we are going to be conveying. So of course, the first thing would be some prerequisites. So you'd actually need to install Wasm-based. I'll be sharing the links to these slides so you can always follow along. But you'll need some prerequisites of actually installing Wasm-based and the Wasm-based QuickJS runtime that would be responsible for actually running this React app inside of it. So once you're actually done with installing all these, we can simply go ahead and use the create React app, npx create React app, to create a basic React application that, of course, a lot of us will be familiar with. And of course, how that would look like is, let me go over here to my code base, and let me see if I have access to that. I'll just put a view here. So yeah, basically what you see is I created a basic React application using the create React app, and I'll navigate back to this particular screen. Now, the next step is to actually start making changes to this default static React app. So the first thing that, of course, we'll do is replace the content of our index.js file, and we'll change the default method with hydrate so that we are able to indicate to the DOM renderer that we intend to basically rehydrate the app once we actually do that initial page load and we render that HTML that we want to render from our Express application. And after we have actually done that, that is the main step where we'll see that now how are we actually capable of achieving the server-side rendering with the help of this approach that we are talking about. So this primarily will basically apply creating a new server directory. Over there we'll create a new index.js file, and this approach is very similar to what, as you know, I kind of covered initially, talking about how you can achieve server-side rendering on your own by using, let's say, a static server, which could be an Express server, and you'll have that Express server basically spit out what is the rendered HTML that you want to showcase, right? Whether it's the app component or it's the rendered HTML as a string that you would basically display on your initial page load when you're rendering your React app. So that is the very similar approach that we're kind of just going ahead with. The only difference is that now we are doing this inside of a WebAssembly runtime. So the features that you'll see, or the code that you'll primarily see, will be a lot similar if you have tried to approach server-side rendering with the help of, let's say, an Express server. So the particular code that I like to kind of point out, which is going to be there in our server application. So this is our index.js file. Now, I'll not go too deep into explaining each and every different part of this particular code base, but what it essentially is trying to do over here, and for that I'll just navigate to the previous slide, is that essentially we are having these three main steps where that server in that server directory, that index.js file, is essentially taking using the DOM render.string method to render the actual app component that you're actually seeing, and that is what is transpiled as that template that will be rendered inside of your React application. And of course, if we want to enable that, we will have to, of course, transpile and compile our application with the help of Babel and Webpack. So we'll be making those configurations as well. So in order to do those, we will just create two specific files, which you can see. One is the Babel rc.json, which we'll have to kind of configure, and we'll also be creating another file, which is the webpack.server.js, which is essentially, the main brains behind understanding that how it will be used to basically take that index.js file that we have in our server directory, take that and actually output the server build directory, which will have all of our main components that will be rendered for our React application. So this is the Webpack server, and again, the link to this particular GitHub repository alongside the instructions that I've of course covered will be shared at the end of the session when I'll be sharing these slides. So the next approach that, of course, we are talking about, and let me go back to the slides. All right. So what we've covered so far is that we initially started off by just changing the main hydrate method so that our React tab is aware that, yes, we will be rendering that HTML on load, right? And then we created a simple index.js file inside of a new server directory that is acting as our Express server, and which will be responsible for rendering our app component. And then, of course, we are making changes or configurations to our Babel and to our Webpack configurations that will be responsible for outputting the actual server output, which has our actual component that will be rendered upon the creation of our React app. And finally, what we have to do is that we'll be updating our script section as well. So the particular use case that you'll see over here is the specific one, which is the dev start server script, is where we are basically telling the Wasm-based runtime. Again, just to kind of recap, what we covered was that the server-side rendering that we are accomplishing over here is with the help of being able to run this entire React app inside of this WebAssembly runtime with the help of Wasm-based and Quick.js, which is our choice for the basically for our JavaScript engine. And what we are essentially telling our this particular script that you see for the dev start server script is being able to take that Wasm-based runtime and finding the specific Wasm file for Quick.js so that it can actually take that JavaScript code or that React code and just go ahead and whatever output is being displayed or the component that you're trying to render, so that it will actually go ahead and render that inside of this WebAssembly runtime. So that is a script that we'll basically run in order to basically test out this application. So when you use the npm run dev start server, it will kick off that express server, it will render that HTML, and it will expose that inside of our React app when we are, to achieve the server-side rendering. And of course, you can make changes to the HTML source. Of course, by default, when you're running a default React application, we simply template. What we are essentially doing is that we're simply just templating our placeholders for those dev elements, which typically might have just been static. We are just now server-side rendering, and we are basically changing those instead of your dev elements that you'll find in your standard React app. And this is, of course, how your application would look like. Again, we are not making any inherent changes to the way that React basically works. We are using that same standard approach that we also used for being able to accomplish server-side rendering with the help of an Express server that you would have done locally on your own. We are just doing that, or we are just implementing that inside of a more secure manner with the help of WebAssembly. So we are not really reinventing the wheel. It's just showing you an alternative use case of how we can actually achieve the same with the help of WebAssembly to provide a more secure and a more efficient manner of being able to enable server-side rendering, especially if you're in a constrained environment and you want more secure application to actually execute. But yeah, with that, these are some of the resources. If you want to look at some of the more examples with respect to streaming SSR, there are some repository links that I've provided, including the code for this demo, for which I have provided the GitHub repository. And of course, what this particular meme kind of shows is, that is Wasm ready to take over the world? Because we are seeing Wasm everywhere, right? It's not just WebAssembly that I'm talking about today, but we are seeing a lot of WebAssembly today in use in like in cloud applications, in serverless applications. So if you are a JavaScript developer, you will definitely come across WebAssembly in some form or the other, or even if you are a React developer. But of course, as I mentioned earlier, that this particular talk does not convey that, hey, the method that I'm trying to portray for being able to achieve server-side rendering with WebAssembly is the de facto way moving forward. You still will probably use server-side rendering with Next.js or in a default React application. But of course, if you are in that kind of an environment where you're trying to run React applications in a more constrained edge use case, then this approach will definitely be useful. And in fact, since I am also part of this open source project Wasm-based, there are some startups, including big companies like ByteDance, which are actually implementing AI on the edge, and they are running JavaScript on the edge, and they are actually trying to implement this approach for being able to use server-side rendering. So, I mean, I hope that kind of also answers the question that, hey, is this even viable to actually use in a production environment? So, I'll not say that it's fully production ready, but of course, it does provide an alternative methodology. And I was having this really amazing conversation yesterday with one of the other co-speakers, and I think one of the correlations that we were able to make out is that how Google kind of approaches crawling different type of websites, and they're able to get information. Similarly, think of this approach as a way to be able to just statically render your HTML components in a more secure manner and just render them as compared to using some of the primary methods. So that's something to probably ponder upon. And I'm here to, of course, have more discussions around this approach with all of you, to know some of the fallbacks, or if you have any strong opinions about this approach, I would love to kind of discuss this with you. But yeah, with that, I'll conclude my talk with 1 minute to leave. And of course, you can scan this QR code if you want to get to know more information about the slides. And of course, the slides do cover this approach. So if you want to try it out on your own, all the different links are there in the repository. And of course, you can connect with me on my Twitter @hardoleup, and I'll be more than happy to answer any questions related to WebAssembly and machine learning in JavaScript and React and much more. So thank you so much. And I again thank the React Rally team for giving me this opportunity. This is my first in-person React conference talk. I have given a few virtual ones. So yeah, I'm super stoked, and I'll be more than happy to take up any questions and interact with all of you after this talk. Thank you.